We can also have examples where we simplify expressions. So here I'm going to simplify using indices rules. So if I give you, for example, x squared 3, we know that we multiply 2 times 3, so that's x to the 6. If I give you x cubed a square over x to the 5th. First, let's multiply 2 times 2, so that's 4. So we have x cubed a to the 4th over x to the 5th. Then we write the base ones. I have the base, which is ones, then subtract. So I have the first power minus the second power. Then I have a to the 4th. So 3 take away 5, that gives me minus 2. And then this is a to the 4th. Now please note, from the rule, a to the minus n is equal to 1 over a to the n. This is exactly the same as me having it as 1 over x squared, a to the 4th. And let's think of it. Let's just look at it this way. If I have a half times 5, we would say 5 over 1 and then say 1 times 5 is 5 and 2 times 1 is 2. It's the same concept here. So the a to the 4th is like the 5. So we just multiply a to the 4th times 1. That gives you a to the 4th over x squared. So remember, treat it like how we have a half times 5. We don't say 5 times 1 and 5 times 2. But we say 5 times 1 is 5 and then 2 times 1 is 2. Same scenario. So if you have to put this over 1 to say 1 times a to the 4th is a to the 4th, and x squared times 1 is x squared, go ahead and do so. My next expression that I'll be simplifying, say we have 3 to the n times 9n plus 2 over 81. Now, we have to get the bases to be the same. So we have 3 to the n times 9 is the same thing as 3 squared. Then we have n plus 2 over 81, which is 3 to the 4th. Multiply 2 times n and 2 times 2. So we have 3 to the n times 3 to the 2 times n, that's 2n. And 2 times 2, that's 4. All over 3 to the 4th. Now, bases in the numerator are the same. So I can write it once and apply the rule that says when you multiply, you add. So you add n plus 2n, that gives you 3n. And then I have my plus 4 all over 3 to the 4th. Because of division, we subtract. I will write the base ones. Then I have my first power, which is 3n plus 4 minus the second power, which is 4. So these will cancel. And what I'm left with is 3 to the 3n. Another example, we can ask to simplify. Say we have 2 to the n plus 3 times 4n times 9 to the n. Let's say 9 to the 2n plus 1 all over 2 to the 5n plus, 5n times 3 to the 3n plus 4. So say we have the following expression to simplify. The first thing, let's get 9 and 4 in its lowest form. So we have 2 to the n plus 3, and 4 is 2 to the 2, and we have a n, and the 9 is 3 to the 2 but we have 2n plus 1. Next, in the denominator, we have 2 to the 5n times 3 to the 3n plus 4. Now I'd multiply the 2 times the 2n and the 2 times 1. That's my next step. So in the numerator, leave it as it is. In terms of the 2 to the n plus 3, leave that as it is. Or what we could do some simplification since these are the same base. Write it once and add the power. N plus 2n, that gives us 3n. And then we have our plus 3 because we can't add a variable and a number. 2 times 2n, that's 4n. So we have 3 to the 4n. And 2 times 1 is 2, so we have plus 2. Rewrite my denominator, which is 2 to the 5n times 3 to the 3n plus 4. Now, because these are below, it needs division. So I write the base ones, and I have 3n plus 3 minus 5n times, the base is 3, first power 4n plus 2 minus the second power, which is 3n plus 4. Now here, 3n minus 5n, that's going to give me minus 2n. So I can quickly say minus 2n plus 3. But this part we have to be careful because the sign affects everything that we have here. So by right, what we have is 4n plus 2 minus 3n minus 4. So these are variables. So 4n minus 3n, let me go ahead and write times 3. 4n minus 3n, that's n. And 2, take away 4, that's minus 2. And that's it. So this is our answer for this question. Thanks for watching. Don't forget to like and subscribe to my channel.